This video is to refresh your memory about what you know about similar and congruent figures and scale factor from last year. We'll start with some definitions. This should be in your notebook, but if not, you can just follow along. Congruent figures. Congruent figures are figures that are the same shape and size. The corresponding angles and sides are equal, and the symbol that we use for congruent looks like this. It's an equal sign with the similar symbol above it. Similar figures, which is our focus, are figures that are proportional. This is the most important piece here. They are proportional. That means that when you create a proportion using two ratios of their side lengths, it is true. So the corresponding angles are congruent. So angles don't change, which makes sense because if you enlarge a triangle or a rectangle, the angles inside will still add to 180 degrees for a triangle, 360 for a quadrilateral, etc. And the ratios of their corresponding sides are equal. This means that the shapes can be different sizes, but must maintain the same ratio. The symbol that we use for similar looks like this. So here's a quick refresh. I am given two similar rectangles right here, so I'm going to put my corresponding or matching sides in blue and then in red. So we could set up a bunch of true proportions here. We could say that the blue over the red in the left rectangle is 2/3, and in the right rectangle is 4/6. Those are equal. 2/3 equals 4/6. We can also check to see if proportions are equal by cross multiplying and seeing if their products are equal. And then we also, instead of doing that, we could look within a shape. So we could look at, in this case, the short side between the rectangles. So the small to the big and the small to the big. So our small rectangle to the big rectangle. 2 relates to 4 the same way that 3 relates to 6. We could also even talk about the scale factor. So we would multiply by 2 in each of these corresponding sides, and we'd see that we get to the larger rectangle. So the scale factor stays the same. So the sides are proportional. The scale factor from the big to the small would actually be 1/2, right? Because we'd have to multiply by 1/2 from 6 to 3 and 1/2 to get from 4 to 2. Versus if you looked at this one, if you set up any of those ratios, like 2/3 does not equal 4/7. If I'm looking like within a shape or between the shapes, 2 to 4 for our corresponding sides does not equal to 3/7. So we're just going to do a few examples here. So I want you to skip ahead. I'm going to go all the way down to example 1 and cover some of the big ideas here. So it says, given that triangle ABC is similar to triangle DEF, find the values for x. So first, just looking at this statement here, that actually gives me a lot of information. It tells me that my triangles are similar, which means that my angles are the same, and more specifically, the angles match up. So angle A and angle D are actually congruent. So I'm going to highlight them in the same color. And then angle B and angle E are also congruent. Angle C and angle F are also congruent. So the order is important there. If I were to mark this in here, I could mark these with 1 line, 2 lines, 3 lines to show that those are 3 different angles. And I have a bunch of different ways that I could solve for x, and so we're actually going to show 2 different proportions. So I know that between my shapes, my side here, my 9 relates to my 3 in the same way as, let's use maybe this side here, my x relates to my 2. So I could set up a proportion. My 9 relates to my 3 the same way my x relates to my 2. And I would solve this using cross multiplication. So 3x equals 9 times 2, which is 18. And I get x is 6. In that case, I was comparing, I could kind of use my finger and go like this and use the same motion here to go from 9 to 3 and then x to 2. You want to make sure you're doing the same motion. if you go with different motions, for example, sometimes I'll see students do something like this. 9 is to 3 the way that 2 is to x. Well, that was two different directions, so you will not get a correct proportion. I also can look within a shape. So I might be looking at this side to this side and this side to this side. So x relates to 9, my pink side to my red side in one shape, the same way my pink side to my red side in the other shape. X to 9 equals 2 relates to 3. I end up getting the same equation here when I solve. 3x equals 18, but it is a different proportion. So you might have a different proportion than someone else. You should still get the same value for x. And I could have also used the scale factor here. So I could say, all right, how did I get from, I'll probably go in this direction because I think it'll be easier to see. How did I go from 3 or 3 times what gave me 9? Well, 3 times 3 gave me 9. My scale factor was 3 to get from my smaller to my bigger. So I'll see a lot of students just write this. They'll write times 3, and then here they'll write times 3. That is a perfectly valid method. So 2 times 3 equals 6, and that also gives you the 6. Keep in mind our scale factor going in the other direction would be 1/3, right? It would have been 9 times a third gives me 3. So what times a third gives me 2? 6 times a third gives me 2. So you really don't need to know all of these ways, but you do need to know this information, how to find a missing side. Then we have a little bit of a review here of angles. So it says the interior angles of a triangle always add up to, and they always add up to 180 degrees. So it says if the measure of angle A is 50 degrees and the measure of angle B is 85 degrees, find the following angle measures. First, I'll show you how to do this with the triangles themselves, and then I will show you how to do this without the triangles. So I'm actually going to, I'll just redraw them because that's probably how you might do it. So we could draw this triangle here. I'm just copying it down from above, A, B, and C. And we don't care about the side lengths here because it's only asking about the angles. And this was D, E, F. And we knew that these were the same, that these were the same, corresponding congruent angles. Remember, angles are congruent in a similar triangle. So let's make that look more like a D. All right, and we're told that angle A, the measure of angle A is 50. So immediately I know that the measure of angle D is 50. The measure of angle B is 85. So immediately I know that the measure of angle E is 85. And then we know that all of the angles in a triangle add up to 180 degrees. So far I have 50 plus 85, which is 135. So I'm going to do 180 minus 135 to get 45 as my final angle here in both cases. So angle D is 50 degrees. Angle E is 85 degrees. And angle F is 45 degrees. Now, I told you that we could do this without actually using the triangle, like drawing them. And so I could use this here. So I'll rewrite it. So we know that triangle ABC is similar to triangle DEF. And I already pointed out with those colors above that if these are similar, then these must be congruent. So if angle A we already know is 50 degrees here, then we know that angle D is also 50 degrees. And the next two pair up also. So if angle B is 85 degrees, then we know that angle E is 85 degrees. We would still have to do a little bit of calculating, subtracting from 180 degrees to find our remaining angle for C and F, but it's important to notice that. Sometimes you'll see something like this. It says rectangle ABCD is similar to angle DEFG. So if I'm following this, A to B to C to D, I notice that's my long side first, which makes sense. So that would mean that DE actually corresponds to that first side there. So what I recommend that you do, and on an iPad I could actually like copy, paste image, and rotate, but I always recommend that you redraw this facing the same way. So if we have AB on top like that, and we know that that corresponds to D, then E, then F, then G, then redrawing it and writing in our GD is our 1 inch there, our GF is our X inches. It just makes it clearer to work with. I'll delete this because you wouldn't have that on paper, right? And so then when I'm comparing this rectangle here with this rectangle here, when they're oriented the same way, we are less likely to make mistakes. I'll let you try that one on your own though. Let's go down and look at this last one, number 4. The last one in the video, I mean. It says in the figure, BC, line segment BC, so I'm going to mark that, is parallel to, we have a lot of symbols in geometry, is parallel to DE. All right, well, we've just learned about parallel lines, so this is exciting. So these are parallel. So if these are parallel, then that'll help us a lot. So it says, which means we have similar triangles. And it means we have similar triangles because if we think of this line here as our transversal, these are corresponding angles, so they're equal. If we think of this line here as our transversal, then these are corresponding angles. And then this angle just is its own angle, and that will be in both triangles. So it means we have similar triangles with corresponding angles are equal. Example, angle ABC, so this angle right here, is congruent to angle ADE, AD to E, so this angle right here. So it's just helping us out. It's giving us some information. So what I would recommend is that you redraw out your triangles. So first I'll draw out this one here. So I'm going to draw it down here, A, D, E, this is 3, 4, and X. And then I'll do out my bigger triangle. So that's this entire thing here. A, B, C. I know that this part is 10. And this side is actually 8. Be careful there because we have a 4 and another 4. The side on the left is 3 plus something. You could, make up another variable there. I don't think we will need it because we're looking for X. And we are looking to identify the triangle similar to ABC. So ABC, and maybe I'll add in my angle markings again. So I see these and these. I just want to make sure that I have the correct order. And so angle A corresponds to angle A again. So I'll fill in A. Angle B corresponds to angle D. And angle C corresponds to angle E. And I can always trace it with my finger. A to B to C, A to D to E. That makes sense that those angles are corresponding. We know that those angles are actually congruent, A and A, B and D, E and C. Then it says find the value of X. You can pick whichever way you want. I'm going to set up a proportion between my triangles. So I'm going to say the ratio or the relation of 4 to 8 equals the same ratio or relation as X to 10. So I get 4 times 10 equals 8 times X. And I get 5 as X. Always a good idea to check it using a different method. I see that my scale factor here for my small to my big is times 2. So if I did have X was 5 there, then when I do times 2, I get 10. So I know that I am correct. The reason I like to get you in the habit of writing proportions is that when the scale factor is something like 1.7, it's much harder to tell and much harder to do using mental math. There are lots of other problems here. Feel free to try some on your own. This was just a quick review, or maybe not so quick, of what you learned last year.